Well, good morning, good afternoon, good evening, depending on where you are. My name is Simon Ritter. I am the Deputy CTO of Azul Systems. Our webinar today is going to be about how the choice of your Java runtime, your Java development kit, can have an impact on the development and your DevOps workflow. I'm joined by Rudy. So Rudy, would you like to introduce yourself?
Yep, hi, I'm Rudy de Busser, working for Payara, working there as a developer advocate and technical sales person, so helping everyone to get on board on Payara.
Great. So just a couple of housekeeping things before we get started with the presentation. We are recording the presentation, so we'll be sending you a link to that afterwards. So if you want to share that with your colleagues or your friends or even your relatives, then you can do so. We'll also send you a copy of the slides as well. So again, you can share those as you see fit. Okay, so if we get started with the slides, Rudy, if you can just move to the next one, please. And just a little bit of background on us at Azul Systems. We are a company who's focused purely on Java. And so we are really the largest company who's focused just on Java runtimes. We have been around for quite a while now, well, certainly in IT terms, maybe not in history of the world, but in terms of IT, we've been around since 2002. We're headquartered in Sunnyvale in California. And as I say, the idea is that we focus just on Java. And so we have really two things that we do. The first of those is what's called Zulu, and that's builds of OpenJDK. And you can divide that into sort of three groups. The first is our community edition, which is completely free. You can download it from our website and you can use that as you wish. If you're looking for commercial support, where you can get service level agreement about when you get updates, if you want to have somebody you can call if you have a problem, then we can do that through our enterprise product. And if you're looking at embedding Java, either in a true embedded sense for an IoT device or maybe a printer or something like that, or embedding from the context of using it as something to run an application. So if you want to deliver it to your end users, then you can do that as well. The second part of our business is around what we call Zing, and that's a high performance JVM. We take hotspot from OpenJDK, and rather than Zulu, which is just a straight build, in this case, we actually make some significant modifications to it. What we do is we replace all of the garbage collectors with a thing that we call C4, and that delivers much lower latency by eliminating the issue of garbage collection pauses. And for higher throughput, we've changed some of the JIT compilation system by replacing the C2 JIT compiler with one that we call Falcon, which is based on the open source LLVM project. And if we move to the next slide, please. Just talk a little bit more about Zulu. What we describe this as a slightly enhanced build of OpenJDK. So it is very much the same, except that obviously we as a company will do backporting of the security patches and bug fixes from the current release every time there's an update to older versions. As you can see, we actually support versions all the way back to JDK 6 if people want that, 7, 8, 11, the current long-term support release, and then we also have what we call medium-term support releases, which are 13 and 15. All of our releases are TCK tested, meaning that we run all of the tests, there's about 150,000 of those, to ensure that if you want to switch from somebody else's JVM and JDK to ours, then you've got a very high level of confidence that it will work in exactly the same way. We support all sorts of different formats, different platforms, all the way back to things like 32-bit versions for Windows, if you want to run Windows XP. And a couple of the other things that we've done, which is what Rudy's going to talk about in a lot more detail, is backporting of both TLS 1.3 and Java Flight Recorder to JDK 8 to make that more useful to you. And so, given I just said that, I think I'm going to hand over to Rudy so he can talk about that in a lot more detail and show you how that works. So, Rudy, over to you.
Yeah, thank you, Simon. So when you want to run your application, your web application, for example, you need a runtime to run it, like Payara Server or Payara Micro. But of course, you also need that JVM, and that JVM can play a significant role in the feature that you can provide, or how you can work around some issues or find out things for monitoring and debugging purposes, for instance, with the flight recorder, as we will see. So the JVM is important, and the first thing I want to highlight that is by have a look at the TLS 1.3. That's the latest version of the SSL protocol that's used between your browser, for instance, and your application to set up a secure connection. It was originally only part of JDK 11, but then, yeah, because it was obvious that JDK 8 will be used for a long time, and then there was made a decision that it was also it would also be backported to JDK 8. Update 2.6.1 is the first version where it appears in OpenJDK. But even before that, you could have that option with the Zulu JVM, because they have created the OpenJSSE project, which implements the entire TLS 1.3 so that it can be used transparently on an older version. And by just specifying those parameters, -XX plus use OpenJSSE option of the JVM, then you could have used it already at that version as of Zulu 8.40. So let's have a look at it, how you can configure it within Payara, and how easily you can switch to this latest version of the security protocol. So I have here a environment where I'm running a slightly older version than of Zulu, because I wanted to show you that that TLS is also available in the older versions. This is based on OpenJDK 252, so it's Zulu 8.46. And I can start up then the Payara server here. I have here a standard domain. And when I try to connect to that secure endpoint that we have by default, that's located on port 8181 on the local host, then I can ask through the Java code to list me the protocol which is used when I perform the handshake. I need to have a specific SSL connection factory, because we have by default a self-signed certificate to that secure endpoint. So that means that we have to do some tricks that you should never do in production, meaning that you should allow anything, the anything goes factory is here for demo purposes. But it allows me to connect easily to the server, and by default you see that you get the TLS 1.2 version as the protocol for that connection. Because by default we do not define 1.3 available, because not every JDK had that option. So that means that you need to configure it, and that can be quite easily done through a command line configuration. You can do that also via a web UI, which I will show you briefly. The first thing that I do is disable the 1.2 version to make sure that this version is no longer selected and no longer available. And then the second thing what I do is enabling the 1.3 version. This is only configuration, so there is nothing really changed at the runtime already. So that means that I need to restart the HTTP listeners quickly, so that can be done on the fly, which means that any new connection now should use that 1.3 version. Let's see if it is correct what I say. So running the same program, it says now that it is connecting to the server to that 1.3 version. Have a look at the web console. As I said, you can do it also graphically. If you're not familiar with all those commands, you can learn all those things through the UI that we have. We have here the server configuration. We have here the network listeners. The port 8181 is the SSL-based one, the secure one. Then you see here that we have disabled the 1.2, enabled 1.3, and then you can configure if you want to restrict the available cipher suites to set up your secure connection to a list. If not, then all are available. And the nice thing about this TLS 1.3 is that you can easily see if it's available or not, because you have there that cipher suite with that funny name. I find the Cha-Cha-20 algorithm, which is only available normally in JDK 11 for now, because we have that backport with that OpenJSSE project. So that means it is also available now here for JDK 8. Not sure if there are any questions for the moment already. Then we can handle them at this moment around the TLS 1.3 demo.
Yeah, so we don't have any questions at the moment. In fact, I should have made this a little bit more obvious when I did the housekeeping, but if people do have questions during the presentation, please feel free to type them into the question box on the GoToWebinar control panel, and we'll address them as we go through. And obviously, if there's ones at the end, we'll follow those up as well. So, yeah.
So yeah, if you have any questions, you can always ask them and we can cover them later. So let's switch to the next part, which can be important, and that is the flight recorder. So maybe I'll bring up a little slide which briefly describes how the flight recorder works. The flight recorder is just as a black box in airplanes, for example, that captures a lot of data from all systems which are available. That means you capture information about the operating system like CPU. You capture information from the JVM, the thread information, compiler, threading, memory, etc. You can also create your own events, as you will see in the demo. And all those events are in the first step. They are captured in the global in-memory buffer, so that the retrieval of all those values has less impact as possible on the actual execution of your program. And then later on, if you say that you want to have a dump of that information, of all those events, then you can dump that to a file. Both that in-memory buffer and the repository are circular buffers and file content system in the sense that you can define a maximum size for that file, for instance, so that you only capture the last few minutes, for instance, so that you do not have files which take a lot of gigabytes in space of your file system and maybe give you a problem there because it fills up your system entirely. The idea is that it is designed to have it running all the time. You should only have 1 to 2% at maximum overhead, so that in case there is an issue, that you just can dump that global in-memory buffer to a file, and that you can have all the information available at that point. Or in case there is a crash, for instance, the JVM exits due to an out-of-memory error, that the dump file is created at that moment, so that you have all the information of threads and things which are going on within the JVM at that point. So let's see what it can learn us, and it learned me by creating that demo something very interesting. So you will see at the end that it can give you some very useful information which is not very obvious straight away. So I have here another environment which is running on the on JDK 11 version. Although Flight Recorder is also available in JDK 8, but I wanted to show you that you can use all those tools and the Payara platform, for instance, on different kinds of environments. Let's start it up. That's what I was looking for. So we start the domain, and I have prepared a specific domain this time, and you will see in a moment what I changed there from the default. You can also download the mission control program from the Azul website, which allows you to access those flight recorder files and to analyze them and to give you very useful information about it. You can also use it as a classic GMX bean viewer, so like other tools, so that's also possible, but the flight recorder, you have it here available, and later on, if we select one, you can see that it has a nice UI for all the contents of that dump file. So I have an application also deployed on that domain here. So when I would like to access that demo endpoint, can we have then some insights of the JVM, what it is doing when I am calling that endpoint? So let's start the recording here. So you can, from in the missions control, you can give the commands to say that it needs to starting the recording internally and dump the contents after 20 seconds to a file. So let's start them. The counter is running, and when I then call that endpoint, it returns rather quickly, so you think that everything is okay, that there is no issue with this endpoint and that everything is good. But let's have a look what the recording says, that there are maybe some things going on behind the scenes. The event browser gives you a complete overview of that dump file. For instance, you also have the recording parameters. The configuration of the flight recorder itself is here also available. So that dump file contains a lot of information. It also contains information about the JVM itself. You have various categories. One of the categories is that you have an operating system, so your system where it is running, and for instance, you see here also for the CPU load information, so the amount of CPU usage, and even split out by all the threads that you have running at that time. But you also have a lot of events around the JVM itself, and one of the things which is there always interesting is the garbage collection, and then you see that there are quite some number of events around the garbage collection. So maybe there is something wrong in our server around memory, because garbage collection numbers are quite high. But you also have some nice graphics in the tool, like you can see here, where you can see immediately when you click on that high-level Java application item here, that you can have quickly an overview of the amount of CPU, and then we see that the CPU goes even up to a bit more than 70%, I think, here in this case. And you see also that there is some heap. The heap change, the amount of heap which is allocated with changes, so it rises steadily, and then you have a garbage collection again, up and down, and then you see that even here in that last bit there is a lot of times it goes ups and downs. You'll look more in detail to the memory one. then you can see here at the end that during the last second of that high usage of the heap, there was even 2.5 gigabyte of memory allocated during 1 second, which is of course a massive amount of memory allocations. And then you probably guessed it already that demo endpoint that started a stress test. So it executed code which stresses the CPU and the memory, so to see if everything works well and every system responds correctly on that event. The fact that the call which I did with the curl command on the command line returned almost immediately, and that was just a way to trick you because it just started an asynchronous process. But you can also use it, of course, within your application, which makes it, of course, very interesting, as you will see. I have here created the application which is deployed, and it contains a JAX-RS filter. If you do not know what a JAX-RS filter is, it's not a real problem, but this method is called when the server receives the request from the curl command, in this case, or the browser. And I start an event at that point. This method is called when the request leaves the server, so when the request is finished. And then I end an event and I specify various properties, various information parameters on that event, like the path which was called, the URL, but also the query parameters, because that is most of the time very important to know when you are debugging a problem. But also the media type, if it's JSON is or not. You have also the method get or post, for instance. And I have even here linked the Java method, which is linked to that URL, so that you can start immediately have a starting point in your code to start debugging and start finding out what is going on. This event here is a custom event, a custom flight recorder event. So it extends the JDK.jfr event class. All custom events need to be extending this specific one. And you have then properties for each of those information pieces that you want to keep and store in the file, in the dump file. But you also have labels and description annotations possible. That information is also available in the dump file, so that means that any application which is capable of reading that format of the dump file knows exactly what it is and can display in the UI, for instance, some more meaningful description or information of what that piece of information holds and things like that. So this is a JAX-RS event. So I have here another endpoint for testing. So let's see if we can find out based on the recording on the dump what is going on and what is maybe wrong with that code. So let's start the recording again. This time I know that I need 30 seconds. And we call the endpoint again. It does not return immediately, so it is doing something before it can return the results to the end user. In fact, it will take around 22 to 23 seconds. Well, it's faster now. It's only 19. And yeah, based on the response, you immediately see what it was doing. This is a large number, and you can verify it by all possible means, but that value is a prime value. So we calculated a very large number which is actually a prime number, so only dividable by 1 and itself. Now that we know how what the stress test gives as which pattern it gives on such a flight recorder, can we see what it is doing internally, that program? First of all, I can show you here that custom event that we have created. So that comes now automatically within our event browser. And then we see that there was indeed a call of about 20 seconds, but you see also 2 other calls, and yeah, that was a bit made on purpose for this demo, because you need to realize that when you're doing this, that you'll never work in a single environment. It's a multi-threaded environment. A lot of calls can enter the server at the same time, so it's not always easy to know what is the call which gives you the most of problems. There are all things going on. But the nice thing here is that you can, out of that recording of 30 seconds, you can filter all the events out that are not that did not occur during this period of 20 seconds. So you can store and set as selected focus. Standard, you have only that one event, because I need here to select that it needs to show also the other events from other threads, and then we have now a lot of more events during that period of 20 seconds. If we go to the same view here again and zoom in a bit, then we see that there is a CPU usage, but lower as before. It's only around 32% here at this moment. So there is some CPU activity, and that was the thing that I learned, and I tell you more about it. There seems also to be quite a lot of garbage collection going on. So actually what I did with that example is that I created an algorithm to calculate for that very large prime number, but I deliberately wrote it in a bad way, in the sense that I used a lot of threads, I used a lot of calculations, so it was not done in an optimal way, so I knew it would take a lot of CPU. But this garbage collection activity I did not expect, so I tried to find out what was going on. And you see there are, if you go in Zoom, there are a lot of things going on in that selection. Maybe I can get back to that. Then you see my prime thread, which is running. Well, it does a lot of divisions and calculating remainders on big integers, because I needed to have that big value there. And then I realized big integers are immutable. So I used here 27,000 calculations with big integers, which means that I used a lot of objects just to have that calculation done. And that means, because I've restricted the heap that could be used here in this environment to have that stress test running, that I hit immediately the limit of the heap size, because I used that big amount of big integers. So you can see that this flight recorder and the mission control program can give you very useful insights in what is going on, especially if you link it then with your custom events, so that you know which query took long and what were the parameters, etc., so that you can have a good starting point of debugging and investigating your problem. Any questions about this flight recorder demo?
So I'm not seeing any questions at the moment. So I think probably if we move on, and then we'll take questions later on.
Yeah, at the end. Okay, fine. Switch environments again. And with the third option is what's called the class data sharing. I'll give first a bit of background of why that can be important or for what reasons it can be used. So I suppose that you have a system where you can sell tickets for events. Yeah, I know it's not very good example in these times due to all the things going on in the world. But anyway, you have a system for the tickets, and of course, if you announce an event, then you can expect that there is a rise in the number of requests because a lot of people want to buy such a ticket. And your entire system is designed to run properly, to handle up to a certain amount of requests that's indicated by that blue line there. And yeah, if you go over it, you need to start up a second instance of your microservice or another instance of microservice in that case. But of course, starting it up takes a bit of time. It can maybe take only a few seconds, but during that period of those few seconds, you can have dropped connections because your system was overloaded, or you had a bad response for those people who were just trying to connect at that time. So it's not the most optimal way. So maybe then you say, well, let's start a bit earlier. Let's start the system, the additional system a bit earlier. But then, as you can see, that at the bump, that bump just before the large surge, well, that did not go over the line. So maybe you started up an additional instance and you paid for it, and it was not needed. So starting up a new an application with a runtime, that should be done as fast as possible, and that's not just related to that cold startup problem which you encounter with serverless. It is a general thing that things are beneficial if it starts up faster. You can do a few things to get faster startup. One is one of the things that you hear a lot of these days, because if you ask me, it is a bit of a hype, is that you have that native compilation for Java. But then, of course, you need to rewrite probably your application. You need to use specific frameworks. You need to use certain patterns to be able to have that native compilation. But yeah, you have your application. So currently running, that might be an old Java or Java EE or Jakarta EE application. And luckily, we have then that feature which is called class data sharing, which makes it possible to start up your application faster, because during startup, a lot of classes are loaded. You have the bytecode available in jar files or class files. And of course, they need to be loaded. They need to be verified to see if the bytecode is valid for that JDK, and if it's not tampered with, and all those kind of things. So that takes a bit of time. If we can work around that time that is needed to load all those classes, then we can get a faster startup without the need to rewrite anything. So even your very old Java Enterprise application of 10 years old, you can give it a major boost by just using that class data sharing. Class data sharing is a bit of a strange name, if you ask me, because it's not about those static variables that you have, for instance, in classes to share data, but it is sharing the class information, because that arga file that we will create with a specific format for those classes can be shared between multiple JVMs, and then can also result in lower memory usage, for instance. So let's see it in action, what you can do to get your application started faster. This time it will be a Payara Micro version. Payara Micro is a runtime for applications. And it is in a single jar file. So it is you do not need to install it and then configure it. You can immediately run it. I'm going to run first this command, which is the normal way. You start up your Payara Micro instance and you give the location where the application or multiple applications are located, multiple WAR files are located, and it starts up, it deploys the application at the same time. You can do the configuration on the fly, and your application is ready to serve requests from your user. This is a default run, so this is a reference that we will use and see if we can get something done faster than this 9.5 seconds for the moment. Is it possible? Yes, it is possible, but it is a bit of work, but you can work around on those different steps as we will see later on. The first thing that we need to do is to make sure that we have a consistent class path. As I mentioned, class data sharing as CDS is all about the class path, which means it is very sensitive on the order of jar files in a class path, etc., because that can influence the class that is effectively loaded. Payara Micro, that jar file that you see here, in fact, it is just an executable jar file, but the first thing that it does is unzipping itself for the most part of it, and then that unzipped in that unzipped directory, it is looking for jar files and classes files and add it to the class path dynamically. And as you can guess, that's something that CDS doesn't like. So that means that we have created a other option, what we call a output launcher, which creates a new executable. It expands that jar file, and it also creates a new, as you will see, if I list the directory, it also creates a new jar file, which again is a executable jar file, but now with a fixed class path because it knows all the jar files and classes files within this lib, for instance, and within the applications which you have specified on the class path. So that's step one. The second step that we need to do is give a list to that process that we will see later on, which contains a list of all the classes that we want to prepare. So the idea is that we prepare a class so that it can be loaded afterwards very fast. So no longer the need to do the proper loading, the verification, and all those steps that can be skipped. Since a simple application with Payara Micro and the JVM, using a lot of a few things of the JVM, like arrays and lists, for instance, then you easily get to a list of 10,000 classes. So creating that list by hand is nearly impossible. So we can luckily do it in an automated way by using this command. If you specify the dump loaded classes list, then the JVM will record every class it loads in this classes list. We are using our launcher that we have created, and we have also added for Payara Micro a property warm-up. That means that when the system is up and running, so it should be ready to process requests, then it just shuts down, because we have now enough information in this classes list file for our purpose. So it contains classes from the JDK itself. It contains classes from Glassfish, but also because that's part of the Payara server, the original version of the Payara server is based on Glassfish, but you have Glassfish specific files. And if you go up, you would also see classes from your own application. So now that we have the classes, we can ask the system to create that dump file, that archive file, which is prepared for a run later on. So with the -x share dump option, we instruct that the JVM will create that dump file, that archive file, sorry. We can give it a name here. We also need to specify that classes list file with those 10,000 files that we have created. And we specify here the option, the launcher, so that he knows where he can find all those classes. And then he goes over that long list, and then he finds, for instance, that there are in that list classes that he cannot find because it are dynamic proxies. So dynamic proxies can be created at runtime. That class, the bytecode for those classes are not available now here in outside an active running JVM. So then, of course, he does not find it and just gives us a warning that it will not be possible to create a corresponding entry in that archive file. You also see that there are some warnings about that a JDK6 file or older is not supported. So that means that you have now a good excuse to update your older dependencies and make sure that you also use the latest version of any framework that you're using. And then at the end, it gives you some information, and then you see that it has created a file of 160 megabytes large. That seems a lot. That is also a lot, but that file contains the entire class, the entire classes of the JVM, Payara Micro, and your application, which is required to run your application. So you have created more or less a custom JVM. Let's have a look at that file that he created, because it is actually, for those who knows the term, it is a memory mapped file. That means that this file is actually added to your process at the runtime in a way so that the process directly accesses the contents of this file as part of its normal execution. That's the reason also that it is read-only, so for all users, so that it cannot be tampered with, because of course that is the idea. This file, the contents of this file should be trusted by the JVM and can be read immediately without any verification. Last step then, and then we are finished, is that we can actually run then our application with that archive file specified. It starts up Payara Micro again, as it was our reference run the first time. And remember, it was 9.5 seconds to start up. Now it is only 6.7 seconds. So that means we have done tests in a more controlled environment like this, and on average we have an increase of startup time with 35%. So without changing anything on your application, without rewriting it, without using any specific construct, whatever, you can achieve quite some benefits in startup. All those steps, of course, you should not do them manually. You can create a script, of course, for this. But today we have also, of course, the possibility to use Docker. In a Docker build file, we can put all the required commands, and I'm using that here as in a multi-stage Docker file so that I can have the optimal layering within my Docker, because all those additional executions generates a lot of files, temporary intermediate files, which are probably not needed at the end. So a multi-stage Docker file is then, of course, the most optimal solution, starting from the Alpine version of JDK 11, again from the Zulu distribution. I add there a few things Payara related, so I create a group and a user. I copy that Payara Micro at the correct location, and I create that output launcher. That was our first step. In the second step, then, based from that micro base build that I did in the first part, I'm creating that classes list, that list with the 10,000 classes in, and I create this archive file, that payara.jsa file. And then as a last step, which is the actual image that then will be created based on that prepared one, I'm just specifying the correct Java parameters, so the X share on the correct memory usage for within a Docker environment, that archive file, and then of course our launcher here again to run it. Building it, I did it already before, so that we don't need to wait to before all those steps are finished, because it is basically exactly the same steps that I did manually a few minutes ago. We have then that image which I called micro.warmup, and if I run that image, it starts up, and we can have a look at the log to see if it was successfully warm up. And then you see that again, I have my information that my application with the rest endpoints are deployed. It takes now again more than those 6 or 7 seconds because I have limited the amount of CPU cores which Docker can use. So I only assigned 2 of them and not the entire 12, which means, of course, that it goes slower. And for those who want to have the final proof that it's still working, our application with that archive file, I can call an endpoint within this application, and you see that the hello world style thing still is working. So, are there any questions around using this CDS?
I'm still not seeing any questions, so if anybody does have questions, please feel free to type them into the Q&A box. So, because yeah, I don't know if you want to just finish off the last couple of slides, and then we'll see if there's any questions after that.
Okay. So yeah, so this was the one, the 35%. And then a bit of promotion. As Payara, we also support community with events and jugs, etc. So if you're interested, you can have a look at our page there. Also, we have put here the download links, the download links for Payara, so that you can start playing with the community version. And also the link to the Zulu downloads is presented there, and the links to a get started for Payara and the Azul site. So that is it about the presentation itself. So.
Okay, great. Well, thank you very much. Yeah, okay, so we do have a couple of questions here. So question, what is the advantage of using TLS 1.3?
Well, yeah, the TLS 1.3 has mainly two features, functionalities in it. The first thing is that it limits the number of cipher suites I showed you there on the screen, which are in there. Those are only a limited one if you compare them to 1.2, because all the older ones are removed. The older ones which are used on a less secure algorithm or less secure byte length. For instance, the things with short keys, etc., are removed, so that you have a stronger security, you have a stronger encryption, so that makes that your TLS 1.3 connection is more secure, more difficult to tamper with. And the second update is that the handshake is changed, which means that for TLS 1.2 you needed 2 round trips, two times back and forth to the server to get your secure connection established completely. Now with 1.3 it is only 1 round trip, so that means that you should have a faster connection, because that's most of the time some complaints about SSL that it was a bit slower or too slow. I tried to get a number on that, but it was too little to be really noticeable on my machine. So that's a thing that I left out of the demo.
Interesting. Okay, another question. Does it make sense to switch on flight recorder the first signs of trouble being detected?
That is an option, but then you can ask yourself the question, when do you know when there is an issue? So, so it probably is much easier to just have it running all the time, as I said, and just ask for a dump file when you see or expect that there is an issue, because you see some other indications on other monitoring tools that say that something is going wrong. In theory, you can do it, because I did not show it, but you can, with the JCMD command line tool from Java, you can switch the flight recorder on and off and create a dump file, etc. But I think it's much easier to just keep it running and have it and have a dump file when you need it.
Yes. Yeah, I think one of the things that's worth noting about flight recorder is because a lot of the information that's collected as flight recorder is statistics that are already being gathered by the JVM, the overhead is very small. So running it in production doesn't detract from performance in any noticeable way. So yeah, it's a good idea if you are thinking that you might need to detect something, then just turn it on and run it all the time. Is it possible to use application CDS for any application on runtime?
Yes, in the sense that the few restrictions that you saw already. If you have a lot of old classes like JDK 6 and older, then you will not have the maximum benefits. But any application which can be run on Java can be changed to use that application CDS, so that the class path is already inspected up front, and is that Archa file is created up front. So any application, I did not come across something which was not really usable.
Okay. Okay, so this question actually is for me. You mentioned that you perform security patches. Are you looking at the Nessus professional vulnerabilities to determine what patches are needed? How often are patches implemented? So the way that this works is that essentially what we're doing is we're taking the security patches which are generated for the current release, And the way that that works is through what's called the OpenJDK vulnerability group. And what that means is it's actually a collaboration between a number of companies. Azul is one of them. So our engineers actually developed the security patches which are used in OpenJDK alongside people from Amazon, Red Hat, Oracle, obviously, and some other organizations as well. SAP is another good example. So what we do is we work together to figure out what security patches need to be developed based on the vulnerabilities, the CVEs that are being reported. And then we do the backporting of those to the older versions. Now, a lot of that is reasonably straightforward, because if you've got a patch that applies to a particular library file or a particular source file, if that source file hasn't changed from JDK 8 to JDK 15 or 16, then it's a very straightforward thing that you can just move that patch back and there's no real effort involved. What does get more complicated is when there have been changes between an older version and a newer version, which is when we need to do the actual backporting work and figuring out, do we need to make those changes? If files don't exist, then obviously those things don't need to be changed and stuff like that. So we don't use things like the tool that you've asked about there, the Nessus Professional Vulnerability, because we work as a team on these things. In terms of how often that happens, the OpenJDK provides updates on a quarterly basis. So there's one in January, one in April, one in July, and one in October. And so we follow all of the same update releases. So that's the way that it works in terms of updates to the JDK itself. And we got one more question here. Yeah, can app CDS be used in combination with the module path? That's a good question, yes.
Unfortunately, not from what I read. There are newer changes in JDK 12 and 13 around it, but the model path is not supported for the moment. I think they are working on a solution or an implementation on that, but for the moment it is not yet usable with the module path, only the class path.
Okay. Right, well, we're just coming up to the hour and I don't see any more questions, so I think we'll probably wind things up here. Just to a couple of things to say at the end. Firstly, thank you very much for presenting to us. That's been, thanks a lot, Rudy, for presenting what you've done, the great demos and so on.
Thank you.
As I mentioned at the beginning, we will be providing a copy of the slides. We'll also we have recorded this presentation, so we'll send you a link to the recording. So if you do want to share it with your colleagues, your friends, then you can do so. And yeah, I think that's really about it, since again, there are no more questions. So thank you everybody for listening, and thank you, Rudy.
Yeah, thank you for the opportunity, and see you on another event.
Yes.
Bye.
Goodbye.